All right, hello everyone. I want to get this started on time because FanDuel has a lot in store for us today. Thanks again for joining us here at the Sloan Sports Analytics Conference. My name is Riley Foreman, and I am a second-year MBA student at MIT Sloan. It is my pleasure to introduce the workshop, How to Win at Sports Betting, Building Models and Pricing Odds with Data Science, presented by FanDuel. Please join me in welcoming our speaker, Keith Goldner, Vice President of Data Science, Sports Modeling, and Innovation, to the stage.
Thank you. Excited to be here. We're going to talk through both the data science side and the trading side of essentially how we build models at FanDuel, how we price stuff up for you to bet on. I want this to be like semi-interactive. I'm going to ask some questions. If you have any questions or you disagree with our methodologies or anything, like please raise your hand, and because again, I want it to be more interactive. So just to introduce ourselves, she introduced me. Again, I'm Keith Goldner. I'm the Vice President of Data Science. I run the Sports Modeling and Innovation team, which is just to say that we work on data science focused on sports themselves as opposed to customer marketing risk behavior, where we have other teams to do that. Over here, this is Juliet Gorson. She's a senior data scientist on my team. And Matthew Hammond, or Hamo, he is a sports trading director, and he's going to talk a lot about when they're actively trading and how we come up with different market ideas. But I'm going to jump right in because we got a lot to go over. So generally, the life cycle of a market, from idea to it being on your phone or the website for you to bet on, we come up with an idea, and the traders are the main people who are getting that on site. They're either manually pricing up markets, putting them on site, or they're the ones who are kind of monitoring the live feeds, make sure things look good before they go on site. And where we fit in as a data science team is they're basically our customers. The traders are our customers. So we're doing everything from one-off ad hoc queries where they might say, okay, what's the probability for the Super Bowl that the opening kickoff is a touchback, where we might run a query or build a quick model, to building dashboards and other tools to let them essentially price up whatever market it is, might be player props, to building these full-scale simulation models where it's what you're seeing when you're live, where there's inputs going into it, and it creates all the derivative markets. It allows you to bet on same-game parlay, and we run all of that to work with the traders so that we have effective pricing. I'm going to give this over to Hamo to talk a little bit about how we come up with the ideas for new markets.
Thanks, Keith. Yeah, so there's a few different reasons why we might want to offer a market for the first time. Quite simply, first one would just be we want something new for our customers to bet on. We obviously are trying to attract as many customers as possible, and we're also trying to keep the customers that we have happy, and new markets is a good way of doing that. Customers themselves may request the markets. This is quite common. A lot of people might not know it, but you can easily sort of tweet us, or you can contact our customer service and request markets. It's not necessarily going to always be answered, or we're not always going to do it, but it is an avenue. If there's sort of repeat requests from customers, then we might be like, okay, we want to give them what they want. Another reason would be the media narrative. If there's like a milestone coming up, if someone's retiring, if there's a streak going, we want to kind of enter ourselves into that narrative. So we might look at pricing some markets based on that. The competitive landscape, if a competitor's doing it and we're not, we don't want to give our customers a reason to leave us and go to someone else. Regulatory updates. So one big part of our role as traders is making sure we're compliant, and each state has different rules. If one of the regulators decides to change their rules or relax something, then all of a sudden we can offer that market. It may make more sense for us to then go after that, because previously, if we could only do it in one state, it might not be worth the time and effort. And ultimately, we want to increase our handle or our turnover. We want customers betting with us, providing our prices are right. That would end up in revenue for the business. And Keith's going to tell us how we get our prices right.
Cool. So I'm going to give through an example. We're going to talk through from a data science perspective how we would actually build a model to price this up, all the considerations that go into it. So for this, the example, we just had the Super Bowl. How would you price a live field goal attempt? So essentially, we want to offer a market on site. Is this field goal that's about to be kicked going to be good or not, and allow people to bet on it? So building the model portion of it. So just to start, and this is the way you should start about every single type of model that you're building. It's not only applicable just to sports, it's applicable to data science across the board. The very first question you should be asking yourself is, what are you trying to model? And in particular, what is your target variable? So I'm going to open this up to the room if there are people who are willing to answer, but in our case, where we're trying to price a live field goal, what should the target variable be like, because when we're actually modeling, you need some sort of target column, or in some cases, multiple targets that you are running the code against to generate that model. So anybody have any ideas for what the target variable should be in this case?
The probability of the field goal being good.
Okay, so we're trying to measure the probability of field goal being good. So the target should be like a 40%, 50%, 60%. Okay, cool. Any other ideas or thoughts around what the target variable should be? Score and time in the game, okay. Anything else? So we're looking for the target, what we're actually trying to predict, as opposed to potentially features. A binary success, 1, 0. Okay. So in our case, there are a bunch of ways that you can go about this, but a field goal is essentially a Bernoulli trial. It happens, there's a make or a miss, or 1 or 0, and that's what we're going to do to model in this case. He over here talked about a continuous variable, so like the 40%, 50%, you can do that as well. You can do a standard linear regression. There are some downsides to that, which is that you can end up with impossible values. You can end up with a percentage over 100% or a negative percent if you do it that way. Whereas if you're using 1s and 0s and using the right types of algorithms, it's going to confine your results to an actual probability. That's what a lot of those models were built for. So we've got our target. A maker is a 1, a miss is a 0. The next step, and again, at this point, you shouldn't have the answer for, hey, here's the exact model we're going to be using, but it's good to think about what types of models you might ultimately want to use. So having an idea, we're going to talk about how you actually pick a model later, but opening this up again, what type of model or, would you think about using in this case?
Logistic regression.
Logistic regression, okay, great answer. What other types of models? SVM classifier, okay. Any others? A decision tree? Okay, cool. Yeah, these are all great answers. They all fall under the binary classification group of algorithms and models. So logistic regression is one of the more simple ones. You have SVMs, random forests, XGBoost. Some of these actually work for both continuous and binary classification type models, depending on how you run them. But you want to have this idea so that once you have everything set up, you know the types of models that you're going to try. Okay, this I'm going to harp on a lot because I think this gets overlooked a ton in data science. So frequently, people are focused on getting the most accurate model they possibly can, and they want to eke out every extra decimal point in terms of accuracy. But the most accurate model in the world, you spend all this time building it, if it is not adopted and if it's not delivered, it has absolutely no value whatsoever. There's a bad habit of people building a model, kind of putting it up on a shelf and leaving it there, and then it never gets used. So from like the very early stages, you want to be thinking about what is delivery actually going to look like for this model. And I like to build that out almost initially with a very simple model, which is what we're going to do here, so that then you can then iterate on the model, but you already have something in production, something you can be testing, and the actual process of getting it in front of your user, in our case the traders, is much quicker, and it's an iterative cycle. So in this case, there's two main approaches that you can do. One is the more automated approach where you have a live feed, the sports feed going into your database or some sort of queue. Your model runs off of that. It goes to the server. It gets pushed out on site, and the trader's monitoring it to say, hey, yeah, that probability looks fine. We're comfortable with that. The second one, which we're actually going to do here, kind of for simplicity, is the more dashboard tool effort where we have the model running based on the data that we've trained. The trader can then input whatever data is necessary, and then they are manually putting it up on site or clicking a button to get it up on site. So this is the avenue we're going to focus on because the top one, there's a lot more engineering and full pipeline involved in it, and we're just going to show how we would do it ourselves in this case to get it in front of the trader. The next thing to think about, so we started talking about this a little bit, what features might you want to include? And again, it's not, hey, these are definitely the best features, these are the ones we want to be using, but you'll notice a lot of this is brainstorming. We see a lot of people coming out of data science boot camps who have learned this stuff, that they just want a large data set and then they're going to figure out, they're going to dive into it, just start writing code and figure out the results. And it's much more of like a, hey, I want to approach this from a critical thinking, problem-solving landscape and figure out all these aspects ahead of time, because the actual process of like training a model is pretty quick. It's a pretty small portion of what we do. So you want to make sure that everything is planned out nicely. So I'm going to open this one up again. We mentioned some of them: distance, we said score and time. We're essentially want to know what is going to have the biggest impact on whether or not a field goal goes in. So any other potential features that people have? Who's kicking it? Okay. The weather, yep. Trajectory. Anything else? Yeah. Stadium. Okay, cool. Yep, a lot of really good answers. So I just made a list here. This is not an exhaustive list, but some things that in thinking about it that might have a big impact on whether or not a field goal goes in. Distance. I think everyone knows that's probably going to be the #1 predictor in this case. Kicker ability is #2. At the NFL level, the difference between kickers is not that much, but there obviously are still the Justin Tuckers of the world, and that can be separated into accuracy, leg strength, and potentially recent performance, if you believe in hot hand effect, that sort of thing. Weather, there's a lot of different components: humidity, altitude, air pressure, wind speed, wind direction, precipitation, and then venue, if it's in a dome versus if it's at altitude at mile high. The offense's ability at preventing kick blocks, the defense's ability at actually blocking kicks. A lot of people believe in the clutch factor, the Adam Vinatieri effect, or icing. So these are all potential things that we could try to quantify. And so that's the next question here: is how do we actually quantify these features? What stats should we use? Because you can say something like kicker ability, and you could use so many different things to actually measure kicking ability. So when you're deciding this is really important too, is you're trying to figure out what actual stats you should use, how those stats might be biased, because you don't want them to be biased, and your goal is to have the most accurate representation of whatever that idea or feature is that's going to be the most predictive. So as an example, I'm going to talk about quantifying leg strength. So how might you think about quantifying leg strength? What actual stats would you use? Any ideas? Furthest field goal made. That's a good one. Yeah. Field goal percentage beyond 50 yards. Yep. Yep. Average kickoff distance. Yep. Yep, yep. He said force the kick, if you didn't hear, like outside of the game if you were measuring it. Yeah. Yeah, the true distance that it's going to go. You see it on the broadcast, like this would have been good from 65, that sort of thing. Okay, good. These are really good ideas. So I wrote a couple of them up here. We said longest kick attempted or longest made. You could take the average of the 5 longest kicks made. You could do the percentage of their kicks over 50 yards, and then this goes along with what some of you said, but you can manually collect the kicking report. They usually talk about it on the broadcast, like, oh, he said he could make it from 61 in this direction, or we saw him during warm-ups making it from 62 in this direction. So that's another potential feature that you could include. But when doing this, you have to think about what potential biases there are. So there's a couple here. One is coaching tendencies. Some coaches are much more likely to go for it on 4th down when you're in that kind of no man's land than attempt longer field goals. And whereas others are going to be more likely. And so some kickers are going to have more opportunities. And kicking in general is like a pretty small sample event. You only get so many per year. And the other one is the location and circumstances of the longest field goal. So we've been talking about that as a potential way to measure it. If somebody's always kicking at Denver, or in a particular game they were kicking at Denver where it's at altitude, it might be skewed by that outcome. And similarly, at the end of the half, a lot of the times you'll see if people are like sort of on that edge range, they're going to try a 62, 63-yard field goal when they normally might not have tried that. So that can bias your data if, for example, you were using the longest kick as a way to measure leg strength. Okay, this is the part of data science in general. A lot of people do not enjoy this, but it's the most important, because if you have, it's the old like adage, garbage in, garbage out. If you do not have good data, then your predictions are not going to be good. And this is where data scientists spend the vast majority of their time, and that's on collecting, organizing, verifying, cleaning, and engineering their data. So collecting, the most common ways to get them are through an API or web scraping, or if you have an existing database. We're fortunate for this that we have an existing database where we have data pipelines set up through many APIs to have that data in-house, but there's a lot of different ways that you can collect the data. And and organizing. Okay, you want to be thinking about from the very beginning, how do I need this data to look so that I can run my code against it, so that I can build a model? And ideally, what you want is it in column format where each row is a different observation. First one is your first predictor, second column is your second predictor, et cetera, and then you have your target variable, or in some cases, multiple target variables in a final column. Okay, verifying and cleaning data. This is, again, what tends to take the longest. I'm going to go through each of these. These are just some things to think about, but again, they're super important when you're building a model. So removing, handling duplicates. Up here, we have the duplicate names in our NFL player database. You can see there's 5 Brandon Williams. It's really important to use stuff like player IDs and game IDs and team IDs to identify them so that you're not attributing the same stats to multiple players or vice versa. We don't want, if we're doing kicker stats, we don't want multiple kickers to have their stats conflated. Similarly, you want to make sure you have all the correct information. So if you look at this top one over here, you might think that that's a duplicate and you should delete it because it's the same game time, the same team, the same detail. They're both Dan Carlson 30-yard field goals. But in reality, if you pull in the game ID and the quarter and the opponent, they were 2 very different events, and we're going to want both of those observations in our data set. So you need to make sure that you're handling duplicates, whether deleting them if they're true duplicates or keeping them in if they're not properly. Second thing, clerical errors. So this is pretty common. I just gave a couple examples here. The first column, we have a field goal that was, the distance was 10 yards. You can't have a 10-yard field goal. It has to be at a minimum like 17, 18 yards. So I'm not saying we should just throw this row out because it might have other good valuable information, but you're going to want to go back, look, see what was wrong, if it was just somebody put in the wrong value. Similarly, we have a negative wind speed. Again, it's an impossible value. We're going to want to go back and look. Maybe the row needs to be deleted. Maybe we can correct it. In the third one, we have it 70 as a string instead of the number, and we have a target that's impossible at -2. Obviously, we can't use that in our model, so we'd want to look back, see if it's usable, make changes. But you should essentially be looking at every single column and saying, okay, what's the minimum value? What's the maximum value? Which of these might not be possible because you don't want bad data in your data set. Outliers. One of the first things you should really be doing is looking at your columns. Histograms are your friend. And it's the same thing, looking at maximums, minimums, outliers. So in this case, we looked at the distance of field goal attempts in 2021 from our data set. We had some around 0, which you obviously can't have. We're going to need to go back and look at those. We had some up around 85 yards, which I've never seen an 85-yard field goal kicked, so you're going to try. Those we know are errors that we're going to want to look at. But similarly, we have this dip around like 42-yard field goal, and so we need to know if that's an actual outlier or it's just small sample size and it's true random variation, which it was in this case because we only have data from 1 year. But it's another thing you want to look at and think critically about, like, hey, is this real or is there an issue with my data? Do I need to go back, collect, clean, and do what we need with it? This is similar to the other stuff about cleaning values, but it's a special case, which is missing data. You'll see this all the time. You can have an empty string for field goal distance. In that first column, we need to have a field goal distance, so we got to go back and see what happened or delete the row. In the second one, we have null values for temperature and wind speed, and this does happen in our data set a lot, and that's because when the game is in a dome or in a closed-roof stadium, they don't record that stuff, and that's still valuable information to have. So what we're going to do, and you'll see, is we're going to actually fill those in with appropriate numbers that we see fit. And then similarly, we have a target variable in the third one where it's NA, and we can't use that, so we need to go check, see if that's real, or we need to delete the row. And then the last thing, which I think is overlooked way too much in data science where people have these hard technical skills, is like you need to sanity check what you're doing. So does your data make sense? So this is just looking, we binned it by distance. On the left, in general, I think this was 2021, as you get further, generally the probability of making the field goal goes down. On the right, we see it does that, and then at like 45 yards, the probability of making it goes way up. Not to mention that it's kind of like monotonic at the top of it. So if you saw this right thing, you should look at this and say, hey, there's something wrong with my data. I need to fix this. I need to go back, start this process over again. Whereas on the left, I think you'd probably feel pretty good about that your data set looks good. So again, sanity checking, making sure it makes sense. Okay, I'm going to give a really quick example of engineering a feature. So wind direction and wind speed. If we have the wind going 15 miles an hour behind the kicker, 30 degrees off center, we could include the direction as one variable. We can include the speed as another. But you can also use a little bit of geometry, trigonometry to try to get the actual vector of the the wind speed behind the kicker or across the face of the kicker, depending on if you're trying to quantify more the leg strength aspect or the potential for missing it. So here, again, a little bit of trigonometry. You can do the cosine of the angle times the wind speed, and that gives you 13 miles an hour is the wind speed directly behind the kicker towards the field goal, and that's the feature that you'd actually want to put into your model to predict is this engineered wind speed behind the kicker feature. Cool. All right, time to get into modeling. We've done all this brainstorming. This graph down here, I just wanted to show that kicker ability has increased dramatically since the early 2000s and before that. So I was looking for generally if kicker ability had stabilized at all, and it looks like since around 2012 it's gotten more consistent. So our data set we used from 2012 onward. I talked about logistic regression, one of the simplest ways you can do these binary outcome things. So that's where we're going to start, and we know distance is probably going to be the single most important factor. So we're just going to build a very simple model to start, logistic regression based on distance, and then we can build out our whole pipeline to deliver it. I can get it in front of traders. I can say, hey, how does this look to you, while we're iterating on in parallel in the background, and see if this is like something that looks good. So I did this part in Stata, for those of you familiar with econ, but it's literally 2 lines of code. It's import the data set that we have and make the logistic regression. We get our coefficients. Logistic regressions are very easy to put into anything because it's a very simple formula, which you can see at the bottom. Looking at it on the left, the red line, the blue line dots are the predictions. The red line is this locally smooth polynomial to see over the data set essentially what those probabilities were. It looks pretty good. I would be pretty happy with this. I would be happy to build out the pipeline, send it over to Hamo and say, hey, are you comfortable with this? While at the same time, we're talking about all those other features, trying to make the model better. And then that's what I was just talking about, which is the pipeline. So we talked about building a tool or dashboard. It can be as simple as an Excel sheet where they have a lookup or they type it in, gives them the probability. It can be an actual tool where they put in the probability, and then, again, they're playing around with it so that we don't then at a later stage have to wait to build out whatever engineering needs we need as we iterate through the process. Okay, I'm going to turn it over to Juliet to take us through the actual code portion. If you didn't see, there is a Python notebook, and the data set is all available online on the Sloan website, where there's a link at the end of it that you can look at. So Juliet is going to take you through this. Down, yeah. Sorry, before she gets onto it, does anybody have any questions up to this point in it? Because I said interactive, but I've mostly just been asking you all questions.
No.
Cool. Oh, there is one? Yeah.
So when you send it to the trader and you're asking them if it looks good, what are they looking at to like say this is good or not?
More like it'd be a sense check, I guess. Does it make sense with regards to the marketplace? If we have other competitors that we can look at, or essentially it's just like the pricing that it's spitting out. Once they give us the data or the percentage, we're kind of converting that. Does it feel right? It's almost just like a second opinion, to be honest. We obviously have subject matter expertise normally. Our guys are like focused on the sport. They're going to know how often field goals are successful. So it's just like another set of eyes on it, essentially.
Yeah.
So I'm curious, how much time do y'all spend trying to build a model that you think is accurate versus a model that's more representative of people's perceptions?
We're,
Things like icing and momentum and things.
yep.
You might know the truth, but you might know.
Correct. Yeah. Our goal is to get the true probability. We want, the more accurate that we are, the more money FanDuel is going to make in the long term. We are fortunate in that because of the VIG, we don't have to get it exactly right. In a lot of cases, we have to get within 2 or 3%, which gives us a little bit of room. If you're a professional sports bettor, you need to be even more accurate than that to beat the VIG. But our essential goal is we want to get it exactly right because that's going to make us the most money in the long term. Yes, yep, definitely. There's a lot of different ways that it can happen, and so biases that are introduced, that's why it is important to sanity check everything that you're doing. It's the same thing when you run a regression. Like, if you're running a regression for how good of an NBA player is, and you see that when their rebounding rate goes up, your prediction is that they're a worse NBA player or something like that, you need to be sanity checking, saying, okay, why is it saying that? Is there a third variable? Like, what's going on here that is telling us that?
We're talking about, like, if I'm the Bengals, I might have my kicker kick a 60-yarder, and if it's 1 of 1, then it's a probability of 100.
Yes. Yeah, that's true. And that's actually something I'm going to talk about later a little bit. But the question that we're asking based on our data set is not actually, okay, what's the probability that if you trot out your field goal kicker that they make it? It's what's the probability that a field goal is going to be good given that the coach decided it was a good situation for them to kick a field goal. So the coach is taking into consideration things like the leg strength and the temperature and the wind speed and all that sort of stuff. Everything in the data set is biased. It's because the coach said, hey, I think my kicker can make this based on what the kicker has told me and the current situation and where we are. So that is definitely true. Cool. All right, I'll let Juliet talk through the notebook.
So first, I think Keith had already said this. So this notebook is available on the conference website. We also have a link. So if you need us to pull up that link, we can do that at the very end. I know some of you probably don't care at all about the coding, so I'm not going to spend too much time on it. Some of you probably just want to know how to beat FanDuel lines. Power to you. But I am going to go through at least some of it to give the people that are interested an idea of exactly how we build these models. The other thing to note is, like, this is a workshop. It's supposed to be a learning experience. So Keith had mentioned how important data cleaning is. And we did leave some errors in our data cleaning. We did this purposefully. We wanted to see if there were things that, when you're working through it on your own, if you can kind of spot some of those errors, how would you actually clean those errors on your own, and how would it actually impact the data? We didn't just leave you hanging, so we actually have the solutions all the way at the bottom. I'm not going to go over those today. But this way, if you're like actually trying to learn how to build your own models, you'll have the data set, and you can kind of compare your work to our work and see how it would change the model. So first thing here, this is in Python, by the way, so we're just loading in our packages, very easy. We're looking at the data, so that's all this is, just looking at the data, and we're changing anything that might look a little bit funky. Like I said, I'm going to go pretty quickly so that those that aren't interested, you guys don't get too bored. So the next thing that we're going to do is we're actually going to look at some of these features that we have as categorical data. So like we have here just a list of stadium names. We have a list of weather conditions. But is there a way that we can actually make those binary? So one of the things that we do is we have a list of altitude stadiums. And we want to make a list. Is the stadium at altitude 1, yes, 0, no? Same thing with closed roof or dome stadiums. Same thing with, is there precipitation? 1, yes, 0, no. So this way we can get rid of some of that categorical data, which will actually make building the model easier. Keith had already talked a little bit about feature engineering, but this is one of the cool things that you can do when you don't have that perfect variable in your data set. So we want to look at something like kicking accuracy or kicking leg strength. Like, that's a combination of factors. So how can we actually use the data that we have to build the feature that we really want to use in the model? So that's what we're going to do next, and we're actually going to feature some of these engineers. Engineer some of these features. So one of the things, and I'm looking at this box right here, so in box 8, you can see right here, this comes from slide 29, which Keith had gone over, which is actually looking at the expected field goal and how that works. And we have a nice example up here. So essentially, we're saying that if based on just distance, if the kicker has a 61% chance of making that field goal, and they do make that field goal, then they would get a plus 0.39. Right, so we're just looking at, did they make it based on whether they were supposed to make it or not? And then we're also going to knock those kickers that were supposed to make it and they missed it. So that's kind of how we're looking at kicking accuracy. And then I know that we had a bunch of different ideas from the audience about how to look at kicker leg strength, but what we decided to do is just look at the 5 longest kicks and an average of those 5 longest kicks. So then we do something, and Keith had kind of talked about this a little bit, is like, how do we make sure that our data looks good, right? So we just created some of these new features. How do we make sure that those features actually make sense? So very easy. Here I'm just looking at leg strength, and we're just sorting it, and we're like, do these make sense? And we can see that Greg's line's like right up at the top. Okay, cool, that makes sense. I do want to see him up at the top, so I'm feeling good about that. We do the same exact thing for kicker accuracy. We already talked about Justin Tucker a little bit. We see him right up at the top. Okay, good. I'm feeling good about that as well. So next we can move on. Now we've engineered these two features. We can start to move on. And the next thing, and Keith had also talked about, like, maybe there's some null data. Like, how do we actually clean up null data? We don't want null data in when we're building these models. So here we're literally just looking at, is there null? Oh yeah, sorry. Quick pause. Dope. Oh, that's probably way more helpful to people. Yeah. I see some of you have it on your computers too, so you're probably following along nicely. So I'll just go back because some of you might be interested in some of these metrics when we were just checking the data here. So here, this was leg strength. So this is just looking at the leg strength and making sure that like our data looks good. Are we expecting these top 5 guys to be the top 5 with leg strength? And then same thing with accuracy. And I was talking about Justin Tucker being right up at the top. Thanks, Keith. So here, this is where we're checking for null data. And we can see that the majority of the null data is in the temperature, humidity, wind speed, and wind direction. And why is this happening? This is happening in our domed stadiums. So what we're going to do, just very simply, is we're going to take an indoor average. So that's 0 wind speed, 70 degrees, median humidity, which is roughly 60%. And we're going to input all of that data into those null fields. And before we actually start playing around with feature selection, we just want to, again, make sure one more time, does the data make sense? So here we're just building a very simple histogram. We're coloring the field goals that were made versus those that were missed. And we just want to make sure, does this make sense? And we see like the very vast majority that are happening at 30 yards and below are made. Okay, that looks good. We're happy. We can see that those coaches that are deciding to give their kickers ones that are greater than 60, that we're seeing some misses there, which all of this makes sense. So next, feature selection. I think that this is one of the most fun parts of data science, where you're actually getting to play around with the features. You're inputting them into your models. You're removing them from your models. And you really start to kind of like tease apart those characteristics that are most important going into predictions. And one of the first things we want to do is we want to look at correlation. So are any of the features that are potentially going to go in the model, are any of these correlated? Really simple example, what week it is and how many games have been played. Obviously, there's going to be a correlation between those two things. We wouldn't use them as separate features because they're strongly, strongly correlated. So that was a really simple example, but we just want to make sure that our features aren't too correlated, and if they are, how do we actually include that in our model? So after we've looked at the correlation among all of our features, we're now actually looking at the correlation between the features that we just picked a couple here, but the features that we think are important to making a field goal, and we're looking at the correlation between those features specifically with, was a field goal made? And we can see that obviously these correlations are going to be both positive and negative. Negative means that they're negatively correlated. And we can still, like here, taking an absolute value. The strongest correlation is with distance, and it's negatively correlated. So the further the distance, the less likely they're going to make the field goal. Very obvious. But I'm glad that our data also tells us that. So this is our short list right now of what we're going to be using. So we've just created, in box 18, we've just created a potential features. And now we're actually going to start to play around with how these features are affecting the model. We're going to build 3 different models, logistic regression, a random forest, and an XGBoost. Today, I'm just going to be talking about the logistic regression. I think I would really bore the whole room if I went through all 3 modeling experiences. But again, we have all of the Python code for how to do the other 2. And one of the most important things that we do before we even jump into training our models is we need to separate our data set into a training data set and our testing data set. And somebody had actually asked, how do the traders know, how do they actually like go through and eye test our models? And we do some of that for them before we even give them the models because we back test. So we want to make sure that we're not back testing on the same data that we used to train the model, right? That is very poor practice. So there's a lot of literature that actually will tell you how to split your data based on how much data you have. We generally see that it's between 20 and 30%. So we use about 70% for training the data, and then we use about 30% for testing the data. So really important to actually do that split before you start your training. So we've done that split in box 20. Then we've built some really, these are totally unnecessary, but we've built some cool functions that are just going to allow us to output some accuracy tests at the end of each of our, at the end when we've trained our model and then tested our model. So these are just always nice to have. And finally, we move into the logistic regression. Really exciting stuff here. So I'm just going to point out some of the stats. This is something that we generally see printed out at the end after you've trained essentially your regression. These are over here. These are all of the features that you've actually included. So we included distance, kicker accuracy, we made binary, sorry, whether it was the end of the half or the end of a game, right? Because we see that coaches' decisions are a little bit different at the end of the half or the end of a game. And we've made that now binary, so we turn like minutes left in game or seconds left in game into just a binary 1-0. And we want to see if that's important in predicting field goal makes and misses. Wind speed, is there precipitation, and is there humidity? And one of the things that we look at is our p-value, which is just saying, is this feature significant? We see that most of these, we're looking at anything below a 0.05, but cut at 0.5, but these cutoffs can be different, right? Like, everybody, I came from a biology background, was publishing lots of papers, and like nobody really loves the 0.5 number. So take that with a grain of salt. But we can see right here that this is the only one that is not below 0.05. So humidity. So that's like the one where we're not really sure if humidity is actually going to be affecting this model. Maybe this is something that we pull out. We know, and this makes sense logically, and it also, we see this in our model where distance right here has a p-value of essentially 0. Or 0.000001. So it's definitely our strongest predictor. So we're just going to build logistic regressions with distance, and then we're going to choose one other feature. Okay, so we're just going to use distance because we know how important that is. We're going to add feature by feature just to make sure that each of the features are actually significant predictors. So I'm going to go through this just really, really quickly. So here's one with just distance, still significant, yes. Now we're looking at, did I pass it already? Yeah, sorry. Kicker accuracy, significant, yes. Okay, cool. Is end of half or game, significant. Wind speed, humidity, or is precipitating, sorry, humidity, and we just kind of looking at these piece by piece. So at the very end, what we've decided for these features that we are going to be using in our logistic regression is distance, kicker accuracy, is the end of the game, again, this or half, and this is just going to be a binary 1 or 0, wind speed, and your binary, is it precipitating? Now we're ready to actually use we're going to train our model just with our training data, the 70% of that data, and then eventually we'll be able to test it. So we've done our training up here, we're doing our testing down here, and the last thing that we see, and really where I'm kind of going to end, is we're looking at our accuracy metrics. So this is saying we're now looking at our testing set, right? So like we didn't use this in the training, and we're now saying, okay, based on our model, we are now predicting, yes, the field goal is made based on these given circumstances in our testing data set, or no, the field goal was not made. But we also have the results. We know whether the field goal was or was not made, right? This is historical data. So we can actually look at accuracy metrics. We look at our prediction, and we see whether that prediction was accurate in the end. And we can look at an AUC, the Breyer or log loss. So these are very common accuracy test metrics. And I'm kind of just going to, we have a couple, again, we have random forest in here, we have our XG boost, but I'm just going to go all the way down to and sorry, I zoomed too far, which is the fun stuff where we're actually starting to compare our models. Okay, so this, if you go through the workshop on your own, you can actually build all of these models by yourself. But here we're essentially just looking, which of our models is best? Just so we know, right, the logistic regression is definitely our simplest model. We have to do a lot more feature selection when we're looking at random forest and XG boost, but they can be very, very valuable. Okay, but here we're looking, we just want to see which one's best. So of course we're going to be comparing the same error metrics across all of those models. So we're doing AUC versus AUC in the random forest versus AUC in the XG boost. We can see that the logistic regression here is the best one. So it's always fun, I think, when you find that your simplest model is the best model, and we do end up seeing that a lot. So at the very end, like I said, We do have some information about what went wrong with the data cleaning, so you can peek at that if you want, but I would challenge yourselves to actually think about the data cleaning process and what we possibly did wrong before you kind of get to the end. Okay, cool.
Thank you, Juliet. Also, in that like XGBoost and random forest section, we get into like parameter tuning, grid searches, and random searches. So if you're curious about that stuff, the art of parameter tuning, definitely take a look at it. I guess before I move on, any questions about the actual coding portion of it, or our methodology or anything like that? Anyone feel like we botched something or did something wrong? Yeah. Yep. Yeah, so the question was about using a validation set versus just training and testing set. There's lots of literature, there's whole classes you can talk about on this sort of stuff. Validation set, at least in my experience, is predominantly used for the more deep learning, complicated algorithmic things to do that parameter tuning. So a lot of the time you have your training set, then you tune your parameters on the validation set, and then you test it on the testing set. Partially because we didn't have the time, but also because we're talking about logistic regression here, didn't feel the need to use a validation set. Yeah. We didn't. Sorry, I couldn't hear you. We didn't cluster the standard errors.
No, you got a bunch of observations. Like you got repeated observations on papers, right?
Yes.
And you didn't cluster the standard errors. So it's overpowered, and that's why the p-value is so small.
I'm not really sure what you're saying about clustering standard errors. Sorry.
Do you have the code in there for the marginal effects? Get past the coefficients in the model?
I'm not really sure what you're asking. Yeah, the coefficients and all that stuff is in there. I'm happy to go through the code and
You can't interpret those coefficients.
okay, cool. Yeah.
I'm just curious how big a fear of overfitting is, considering usually the other costs of having a model or of having a more complex model
Yep.
is usually due to the cost of having a feature or the explainability of the model.
Yep.
Neither of which are really a concern given your setting. So how much do you weigh that importance of we want the best model possible versus the fear of overfitting?
Yep, exactly. That it brings me perfectly into the next slide, which is talking about what the model trade-offs are. So I'll talk about it with respect to this specifically, but I'll go through it as well. When you're actually selecting the model, there's a bunch of different things that you need to think about when making that selection. So I listed a couple of them out here. First one is accuracy. Juliet talked a lot about that with the different accuracy metrics. In our case, the logistic was actually more accurate than the XGBoost, but very frequently the kind of more complicated machine learning models tend to be more accurate. Sometimes that can be due to overfitting. Other things are explainability. So this is big for us. It's not as big as potentially if you're presenting to stakeholders. A lot of times if you're presenting to a general manager or a business stakeholder where you need to explain what actually your model is doing, it's much easier to explain what it's doing with a simple model like a logistic regression than it is with a black box model like a neural network. That is important to us because the traders, not only do they need to have the model, but they need to know what levers to pull in order to kind of change the inputs where the weaknesses of the model might be. And so if they say, hey, why is the model doing this in a certain situation, we need to be able to tell them so that they understand how the best way to use that is. Integration, super important, depending on your tech stack and what your pipeline looks like. A logistic regression is super easy to integrate. It's literally just one simple formula, whereas integrating something like a neural network can be super complicated. Runtime, another one. We're dealing, in this case, with a live market. So the latency needs to be super low. We need to be able to get it out to the consumers, customers as quickly as possible. But there are situations where you're running something once a day or once a week for a model, a recommendation engine, something like that, where it can take a lot longer, and then that's not as much of a concern for you. And then maintainability, this is similar with integration, but how easy is it to test the model and replace the model or iterate on the model? Again, the simpler it is, the easier it typically is to maintain it. But these are all things that you think about in terms of your trade-offs. Cool. Testing the model, QAing it. This is not just with the model, but this is with anything that you build at any time. It's really important to test in QA because you don't want your users to have a bad experience. your goal when you're testing and QAing is that you are trying to break it. You want to come at it with the attitude of like a 10-year-old trying to break a toy that they're playing with. Ideally, this is an automated process, although very frequently it is not. Type of things you want to try: normal inputs, bad inputs. So I give you an example. Put in -5 in this Excel version. It still gives a probability. It's probably not the end of the world, but we probably want to have some sort of warning like, hey, you put in a bad value. Did you mean to do that? Bad input types. So if you put in a string where a number should be, or in this case there was spaces between the 22, it didn't spit it out. That's a bad outcome. We don't want that. We either need it to be able to read something like that or post an error to the trader saying, hey, something's wrong here. Make sure you put in the right value. And then edge cases. This is super important. It's something that in like our hiring process we talk a lot about is, are you thinking about edge cases? So in this bottom one here, we put in 79 yards for a field goal, and it says there's a 9% chance of making that field goal. And so initially you might look at that and say, well, no, there's a 0% chance of making a 79-yard field goal. That would never happen. We need to reconsider the model. But thinking about what I said before, we're not actually modeling just the probability of making a field goal from a distance. It's making the probability of making the field goal given the situation. So in the example where the coach thought it was okay to trot the kicker out, so if Harbaugh sends out Justin Tucker for a 79-yard field goal at the end of the first half at altitude with the wind behind him, because he thinks he might be able to make a 79-yard field goal, then I would be pretty comfortable saying 9% is not a bad estimate. So it's important to think about whether there's actually an issue there or whether it's measuring the right thing. And the last thing is productionize the model. So we built a little calculator here where Hamo can go in. You can say, okay, we have a 52-yard field goal, and the kicker ability, their field goals over expectation. So if you have somebody like Justin Tucker, it goes from a 63% field goal to a 69% chance of making that field goal. We put the odds up there for him. And again, if we need to iterate on this, we can then go in, adjust the model, but we have the actual backend built for the traders to use it. Okay, I think I have one more slide, and then I'll give it over to Hama, who I didn't leave much time. The last thing is that once you're done with the model, you're not done with it. It's an iterative process. You should constantly be testing the model. In sports in particular, there are rule changes. We saw that the ability of kickers has changed from 2000 onward. You don't want to be using data from old stuff that doesn't apply anymore. So you should constantly be testing, iterating on your model. Frequently, you're updating data with a new season of NFL data, redeploying it, and it's an iterative process as opposed to just putting it up on a shelf, because if you do that, then 5-6 years later, your stuff may be way off, and in our case, we're going to get hammered by bad odds that are out there. But now I'm going to turn over to Hamo to talk about the actual trading portion and the things that he thinks about getting it on site and how to trade it.
Thanks, mate. All right, so our time to shine now. The important thing to note with this is, though, we don't always just go straight to the data science team and want them to build a model straight away. Sometimes we'll do our own testing ourselves. So we might have a market and we're not sure if it's going to be popular with customers. So we might just build it manually, might do our own pricing, not go into the detail that they've spent their time on doing that, but sort of just look at our own statistics, come up with something we think is close enough, just use the wisdom of the crowd within the team. If that is then popular with customers, we're like, okay, all of a sudden we're going to do a lot of handle on this. It's going to be visible. It's going to be popular. We need to make sure that our prices are actually that accurate. So that's when we would call in the experts essentially, and they can go into the, more detail. With building the market, we can do it manually ourselves, or potentially we'll have it within our models. So that little dashboard that Keith popped up on screen, we might build that into the model. Every time you're trading a game live, someone's about to attempt a field goal, there might be a little pop-up saying enter the distance and enter how strong or how good that kicker is, and that would just be trader opinion, but then that would spit out the prices immediately so we can get it on site for customers to bet on. There's a couple of different ways. The destination management is referring to sort of our business model. FanDual, our parent company Flutter, is a global brand, so we need to decide to the other brands that we sort of have hooked up to our systems, do they want to take this market? If it's something a little bit more sort of on the left field type of market, then they're probably not. Like, for example, when the Super Bowl was rolling around, you've got your core markets that everyone wants to take, but someone might not be that keen to have the Gatorade colour of the Gatorade market on their brand in like the UK, because they're like, what the hell is everyone even talking about? Ensuring it's compliant. So this little diagram down the bottom, it's a little bit busy, but it's essentially looking at March Madness and across all of the different states that we have a presence or will have a presence. Are we allowed to bet on that market in that state? It's a really important part of a trader. If you're ever going to get in the industry, compliance needs to be front of mind. So here, looking at the national championship, you can see green across the board. Obviously, everyone's allowed to bet on that. But then looking like something with a team to get the number 1 seed, so many different states don't want to bet on that market. It's not actually really tied to the tournament. It's more tied to the seeding process and Selection Sunday. So you can see there's a different set of rules there. The other things with compliance is things like in New Jersey, you're not allowed to bet on any college basketball games that are played in the state of New Jersey or involving any teams from New Jersey. So we've got to make sure that when we put up these markets, it's going to the places that are allowed to bet on it and we're not in compliance breach. Margination and limits is referring to the margination side of things is often called the VIG. So it's essentially that percentage that we take as a bookmaker off each side of the price. So here, if we build this market, and that's a little look at one of our back-end systems, it might look like this. You've got that price will come on site at American odds, obviously, so you'd have minus 133 and plus 106. And then we're taking 5.8% is essentially our VIG. Now, depending again on the confidence in the market is how much VIG we're going to take. If it's a Super Bowl game and it's the spread or the money line, it's going to be really low VIG. Customers can see when it's not. We want to be competitive, plus we have a lot of confidence in those prices. But if you're talking about that Gatorade market again, we don't really have the confidence in it. It could be fixed. Who really knows what the deal with it is? So we might add a little bit extra VIG, and we might have lower limits as a kind of safety blanket for us. Often the compliance world will dictate that for us. So they might be like, you can offer this market, but you can only allow it with really low limits or something like that. So sometimes that's dictated to us instead of our decision. Then you have on-site mapping. You know, where's it going to display? Is it going to be prime real estate? Do we want lots of customers to see it as soon as they come on the website? Or do we want to sort of put it away, and if people really want to go looking for these sort of left field markets, then they can. And then after that, you activate. So once we're on site, the price management life cycle is the really important part for us as traders. These are a few of the different things that we would need to take into consideration once we get that market up on site and we start taking bets. Now, the first one is our customer base. We obviously have information of our customer base. We know who's sharp. We know who we respect. We know who people are going to beat us over a long period of time. So if they're betting on these markets, then we need to use that data to our advantage and be like, okay, we have a low ego here. We know this person beats us. We might move the price because they're betting on that market. There's also things like you might have a tipping line that's got 20,000 people in a Discord and all of a sudden they're about to bet on that and we have that information. It's like, well, if we're going to have all that action on one side, do we want to move our price as that action comes through? If it was a market like the Gatorade market or something like that, then we probably would do that. However, a common misconception in the industry is that we're always trying to balance our book. Something I hear all the time when we're in interviews is that FanDual only want to have a black book. We only want to lock in profit on both sides. It's not true. We want to get to the accurate price as quick as we can and then lay as many bets as we can at what we think is that most accurate price. The company's big enough to take on these large liabilities, and over time we trust that we're getting it right more than we're getting it wrong, and that it's going to balance out over the long-term period of time. So it's a common one I hear. When it's a core market or something like that, it's not true for our business anyway. I can't speak on everyone's. But if it's a sort of lower market with low confidence, then that would play into it a lot more. Competitors and arbitrage, most of you are probably aware of what arbitrage is. Essentially, if someone else has the exact same market up on their site as we do, and if you bet both sides, you can guarantee a profit. They're not traditionally customers that are going to be good for us long term, so we might want to close that arbitrage opportunity, and therefore we're not attracting that kind of customer who a lot of the time is like a bot or something that's just designed to scrape the sites. So we might want to close that arbitrage opportunity. Other times we're like, no, we're really confident in our prices. I think we're going to get it. I think we'll get it right. I think the market's wrong. Let's take on all that business. It kind of depends on how much confidence we have. New information. This is a big one for us. One of your screens as a trader, you're always going to have Twitter open. You've got to catch all the breaking news. So all of a sudden, the kicker who you thought was in there is not playing. So we've got to change our prices. The weather forecast got significantly worse. The venue might have changed. All of those things, as that new information comes to light, you've got to change your prices to make them accurate the whole time. And then our confidence. As we get closer to the game and the market gets more bet into, we might have more confidence in that market. So we might want to lower our VIG. At the very first time when we go up with a market, it might be 2 weeks before that event actually happens. By the time you get to the day of that, we might be far more confident in our prices based on all of those other things. And then we might want to lower our VIG, increase our limits. We're really willing to write, larger bets and take more action on it. And then the traders are also responsible for the customer journey. So, making sure that the market comes down when it should, so people can't bet on an event that's already happened. We want to make sure that we're settling the bets so the customer's getting their money in a quick fashion, and we're sort of responsible for all of those. The one thing that I did want to point out with the liabilities was sometimes you just get these crazy liabilities on weird markets. And one interesting one was, I don't know if anyone saw the Simpsons meme from the Super Bowl. Someone put out a fake meme saying that the Simpsons predicted the score was 34-31. This has gone viral. It wasn't even true, it was made up. But we had a correct score market on site, and all of these people have just piled into it. We wrote thousands of bets, and we had that liability for like $73 million. If that bet was to win, we're literally going to have to stand up in front of the execs and be like, yeah, we lost $73 million because of the Simpsons meme. So this is what I'm talking about, though, with regards to us willing to take on that action. We saw the price, we saw where we were laying the bets, and there was a heap of margin in those bets. We were happy to take them. We're happy to take that liability. We think over the long run it's going to work out for us. So a little bit of a snapshot there of how it'll happen once we get the prices from the team.
I think that's everything. Yeah, I guess. Any questions for any of us?
Yeah, so we would go in and we would manually overwrite that if we have to. If there's an instance where the model doesn't handle what's happening in the real world, then we would go in and we would manually overwrite that. Something like momentum's a really big one. Like, it's quite hard to model momentum. So if you're trading a game live, that's where you need the human interaction. You need someone who's watching the game. If you're trading a game of NBA and LeBron goes down in the second quarter, the model doesn't know that. There's no real way of us, our models aren't that complex. I think it would probably be a waste of time trying to build that. So that's when you need the trader intervention, and they're going to come in and they're going to change the price. Yep, good question.
And the traders are the gatekeepers, so at any time they're the subject matter experts. If they think they don't like what the model they're seeing, they're the ones who are either going to adjust it or do what they want with it. Other questions? Yep. Yeah. So a lot of the live like pricing, it's all automated. Like, we have big tech solutions so that we can do that in real time. But I'll let him talk about kind of the concurrency and the whole the problems associated with that.
Yeah, like our systems, I mean, we had issues with our systems with taking on when we were trying to scale up early on. I don't know if anyone bet with FanDual, like 18 months ago, it was a very different experience to what you do it now. So the idea is that all of our systems are designed to take, huge amounts of bets at a certain time. The liabilities can go out as far as we want them to. There's sort of not as many issues on that front since we got our tech stack in order. It's pretty, everything's designed with that in mind, I guess. So.
But he's also saying we have teams of traders, and traders can trade multiple games at the same time. And so, depending on the sport and how confident we are in the models, and it's a lot easier to trade a lot of baseball games at once because it's a very slow sport than potentially trading multiple hockey or basketball games at once. So we have people in place to set up that entire infrastructure with actual talent to be trading that stuff.
We can also help with the actual modeling of where we think a lot of bets are going to come in. So that's something that somebody on our team did when we were looking at college basketball, which has lots of games, especially on the weekend. And we can actually model which games we think will have the most handle, so we can add the most traders to those games. So another place where we can actually see some data science and modeling.
Yeah.
How do you cope if you see the market moving a long way aggressively from your pricing, but you're pretty confident your pricing is correct, and maybe the market's copying someone who's made an error, one of the leaders put a fat finger in, and all the audience, their folks are copying them. So your price is right, but the market's probably away from you.
Yeah, it's a good question, something that happens a lot. And you'll see a lot of our competitors take their odds from the same place, from a third-party provider. So if you go on like an odds comparison site, you might see six different competitors there, and they're all got the same prices. And we try to build as many things as we can in-house because we trust ours. In the instance you're talking about, that would be one where we'd be like, well, we're confident enough in our pricing. We're happy to take on all of that business because we think we're laying it on the right side. And essentially it's back to that mantra of we got the right price and we're taking as much action as we can at that price. But it's something that you've always got to deal with. It's like, maybe we'll go a little bit closer while we're waiting for them to figure it out. We'll still be the best price, but maybe we don't have to be so different. It's like if a team's 4.5 point favourites and we make them 3 point favourites, we could sit at 4. We don't necessarily have to sit at 3. We're still going to be the best price, and we're still going to write the action where we want. So there's a little bit of management there, and it's like, how strong is your opinion? How far do you want to go?
But it's what you said, it's the confidence. And in this business, you can't have an ego. You need to be aware of what you don't know and where you might not have best information. So that's one of the most important things when being a trader is not thinking like, hey, for sure, I know the exact right price. It's, hey, I might be wrong. Let me look into this.
Yeah. And that comes back to our customers who beat us. We know that they beat us. We've got to have a low ego and respect that information and use it to our advantage, because we shouldn't be doing what we're doing if we're not going to take that seriously.
I was going to say really quickly too, we had an example of this recently during the Super Bowl, where it was just a cumulative touchdown yardage, and we were priced at a little lower than a lot of the other books, and we were getting hammered on that, and it gives us heart attacks, especially on the modeling team who helped set those lines, and we checked and rechecked and played around with the data, and we were really confident with those lines, and we just left it. And in the end, all of the books lost on the over, because there was a lot of touchdown yardages in the game. But it was something that the traders ended up saying, okay, if you guys are confident, we're confident. And we ended up just moving it up a little bit, but we didn't go up as much as the other books. So it does happen often, and it does give us heart attacks when we have to check and recheck our work.
I think we have time for like 2 more questions. So. Yep, so same game parlay is obviously a very hot thing in sports betting right now. There's different methodologies you can go about it, but the general idea is if you build a play-by-play simulation-based model, then you can count up historically how many times LeBron scored over 26 points and the Lakers won, and the total went over 220 points in your simulations. But you still have to make sure that you're getting all the correlations right so that you're not opening yourself up to this giant attack surface where people can beat you with wrong correlations. All right, last question. Yeah.
So you mentioned leveraging winning bettors to your advantage. At what point do you balance using them to move your line rather than getting them off your book and kind of limit them?
Yeah, so it's a common question that always comes up. People are interested in this. Our approach is we still want to get that information, so we want to at least give them an opportunity to bet an amount, probably not the same amount as your just generic one, brand new customer, but we still want to find the happy medium between they still think it's worth their while to have a bet and we can have that information. And so we don't try to do the thing where you just completely close anyone out and get rid of their account. We still try to let them have a decent bet, especially if it's like day of game in a core market. We should be willing to take some action on that, of the different price. So it's like there's a really happy medium in there that's not always that easy to get. If you go too far, then you're probably incentivizing that customer to find a friend to open an account for them or whatever, where we'd rather have a happy medium. It's like, no, we're willing to take your bets. This is our job. But we've realized that you're so much better. And if we just gave you free run, it wouldn't be good for our business. So you kind of got to balance that all the time.
Cool. Thank you, everybody. Our information's up here. If you have more questions, feel free to come up and ask, but appreciate it.